In this slide, we are looking at how we break down large polymers or large biological macromolecules into smaller pieces. This is, for example, what happens in digestion. You eat a pizza, which is full of long chains of carbohydrates and big protein molecules, and in your digestive system, those big molecules get broken down into their individual components, which can then be taken off throughout your body and used to build new stuff with. So if we look at our reaction on this slide, first of all, we want to look at the arrow. Let me get some color here. We want to look at the arrow. And the arrows are telling us that we're starting here and we're going this way, right? So this is our reactant. This is what we're starting with. And this is our product up here. All right. So if we look at our reactant, it's a long chain and everything's hooked together. Look, there's a covalent bond, a covalent bond, a covalent bond. So this is a polymer because it's got the same thing, a gray rectangle over and over again. Now it does say monomer here, but this is the unit that is hooked together to make this polymer. But right now it's a polymer because it's a long chain. These aren't separate things. They aren't oneers, they are manyers all hooked together. All right, so we're gonna break this apart. So we're gonna go from here up to here, and to break this covalent bond, we need to break this bond right here. We need to reconstitute or put back this hydroxyl group on this side and this hydrogen atom on this side. And those come from water. So in this example, we need to use water. Water has to go into the reaction. This is a reactant. We need it to start with. And we're going to take the H2O and we're going to separate the two H's and the O's into a OH, a hydroxyl group, which we can stick on here, and a hydrogen that we can put here. And as you can see, now there's nothing here joining these guys up. They're separated. And the water has kind of gone away and it's now in the form of an H and an OH stuck to the two monomers. This reaction, so this is basically the opposite of condensation synthesis. You're putting water in and you're splitting something apart. In condensation synthesis, you hook two things together and you pull the water out. In this one, we're going to put the water back in and separate the two things out. And the name of this reaction is hydrolysis. And so this means hydro means water. We already talked about that. Hydrophilic, hydrophobic. Hydro means water. And then lysis, this is a term that we're going to see a lot this semester. Lysis is a word that means bursting, breaking, or splitting. When you see lysis at the end of something, it means something is breaking. So what this really means is breaking something using water, hydrolysis. But we tend to run it together and say hydrolysis. So an example of this is digestion. And it doesn't really matter what you start with, what this polymer is. The process, it could be protein, it could be carb, whatever, it could be DNA, whatever it is. If you want to break it down, you need to put in water and separate the monomers by this process of hydrolysis. So again, a one-size-fits-all reaction to remember for breaking down a chain into its separate individual pieces.